So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a quick topic test with a collection of some GCSE exam style questions on Pythagoras Theorem at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now, before we get started working through this Pythagoras test, it's worth noting that there is no indication about whether certain questions would appear on a calculator or a non-calculator paper. So what we'll do is we'll just make sure that we show a full working out and show you what calculators to use. So if it's not on a calculator paper, you may have to do some either long multiplication or some long division. So let's get started on this paper. So looking at question 1, it says, for this triangle, which of the following is not true? So it's really important that you do read these multiple choice questions and also true and false, because they may have that word of not, which again can really throw a lot of students off simply because they've not read the question carefully. So we're looking for which one is not true. So looking at this one is going to be true. This one is going to be true. And this one is also going to be true. So the one that is false is the second option. Looking at question 2, it says work out the length of x. So for this, we're trying to find one on the smaller side, and also note that it's only worth 2 marks. So for this, ideally what you want to try and do is label the triangle first, and also notice that we're trying to find the smaller side. So now to find the smaller side, what we've got to do is square the two numbers that we know and subtract with the bigger number going first. So here we've got we've got a squared plus b squared equals c squared, and which we're trying to find a. So a squared equals c squared minus b squared. So substitute numbers in, we get x squared equals 22 squared minus 15 squared. 22 squared is, and that all is going to give me 259, and so that's what x squared equals. So and then working out what x squared is, so we can then work out that x is going to be the square root of 259. And there's a couple of ways in which you can write your answer. You can either write it as a square root, or you can actually work it out on the calculator, which gives me an answer of 16.09347694. Or you can have an attempt at rounding this answer, which would be 16.1 centimeters, and that's to 1 decimal place. Moving on to question 3, again we've got to just do basic Pythagoras. So here we're trying to find the longer side, so that's c, and when we're trying to find the longer side, we square both numbers. Oh, don't know what's happened there. Move up a little bit. So we square both numbers and we add. So it's 11 squared plus 18 squared equals y squared, and working that all out, we get that y squared equals 445. So y equals the square root of 445, which in exact form I could leave it as that, or you could type it into your calculator, do some rounding, you should have an answer of 21.1 to 1 decimal place. Now there is no indication about how they wanted me to write the answer, so either you can just simply write whatever's on your calculator, or you could round your answer. But if you have rounded your answer, always state what rule of rounding you've used, whether decimal places, significant figures. Don't go for truncating, but I would say always state to what degree you have rounded those numbers up as well. So for question 4, it says work out the perimeter of this triangle. Now to work out the perimeter, I need to know what all the sides are. So what I need to do before I work out the perimeter is to work out what this length here is. So let's just call that x. So to find x, that's going to be 9 squared plus 40 squared. So x squared is going to equal 1681. So therefore x equals the square root of 1681. So I can scrub that x and replace it with the square root of 1681. Now to work out the perimeter, I've got to do whatever the square root of 1681 is, plus 9 plus 40. And if I do that correctly, I should end up with an answer of 90, because the square root of 1681, not that you should know off by heart, because I clearly do not, but is basically 41. So I could write 41 plus 9 and get the answer of 90. Moving on to question 5, it says that a ladder of length 4 meters leans against a wall and is 2.8 meters high. The foot of the ladder is 1.2 meters from the base of the wall. The length of the ladder above the wall is marked as x, and the question is asking us to work out the value of x. Now the first thing we need to note is that the total length of the ladder is 4 meters. Now for this, what I need to do is I need to work out what this length here is. So if I take that triangle out of the question, do very poor triangles, so that's 2.8, that's 1.2, and this is what we're going to call as y because we've already used x, so we go from there. Now with this, I've got y squared equals 2.8 squared plus 1.2 squared, so y squared is going to equal 3.05. So if this length here is 3.05 and all of that ladder is 4, then what I get is 4 equals 3.05 plus x. So x equals 9 minus 3.05, which equals 0.95. And that's going to be in meters. Moving on to question 6, it says that the area of this triangle is 330 centimeter cubed. Work out the length of the hypotenuse. So here, to work out the area of a triangle, we know that it's base times height divided by 2 equals the area. So substituting numbers that I know of this, so I know that the area is 330 and I know that the base is 60. And we'll replace the height and we'll just call it x. So from this, what I've got is I've got 60x divided by 2 equals 330. So 60x is going to equal 660. So x equals 660 divided by 60. So x equals 11. So from this, I can scribble that and put 11. So now I can use Pythagoras to now work out what h is going to be. So h squared equals 11 squared plus 60 squared. So h squared equals 3721. So therefore h equals the square root of 3721. And again, no indication about how they want the answer written, but basically that proves to be nicely 61. So again, I could either leave my answer as root 3721 or work it out on my calculator and get an answer of 61. Then moving on to our last question, it says that this triangle and square have the same perimeter. Show that the square has an area 50% greater than the triangle. So for this, let's have a look at the first bit of information. So it says the triangle and square have the same perimeter. So the first thing I need to do is work out what this length of the base of the triangle is going to be, and I can use Pythagoras to work that out. So here I'm going to have 10 squared minus 6 squared equals x squared. So x squared equals, and we can work that out as being 60, so that's going to be 100 minus 36, so x squared equals 64, so x equals 8. So then working out, so that's my first step. So the second step is then knowing the perimeter of the triangle is going to be 6 plus 10 plus 8, which is 24 centimeters. Then from this, what I can then work out is the area of the perimeter of the side of a square. So side of the square is going to be 24 centimeters divided by 4, which is 6 centimeters. So that's going to be 6, and this is going to be 6. So then working out step 4, the area of the triangle, which is base times height divided by 2. So it's going to be 6 times 8 divided by 2, which is 24 centimeters squared. And then working out the area of the square, that's going to be 6 times 6, which is 36 centimeters squared. Then if I then do 36 divided by 24, I get 1.5, which equals a 50% increase. So therefore we have showed that the area of the square is going to be 50% times more than the area of the triangle.